So hello everyone and welcome back to a brand new video, and in this video I will be covering problem KFLIP from Codechef Status 54 like I promised in my last video. So let's start with the problem, that is KFLIP. Let me open up my drawing pad. So in the problem we have been given two integers n and k, where both n and k are around 10 to the power 5. And we have been given a binary string s of size n. We have been given a binary string s of size n, s1, s2, s3, so on up to sn. So it is a binary string, so it is a form 0, 1, 0, something like this, right? It is a binary string. You have been given an operation. You have been given an operation. In one operation, you have been given this integer k. So in one operation, you can select any k indexes. You can select any k indexes. Let's say these are k indexes. And you can flip these values. So in one operation you can select any k indexes from the string and flip these values. You can apply this operation any number of times. And you have to tell the different number of binary strings that you can form using this. So as an answer you have to tell different number of binary strings that you can form after applying this operation any number of times. So that is the problem. So given a binary string of size n and an operation in which you can select any k indexes and flip them, you can apply this operation any number of times, and you have to tell the different number of binary strings that can be formed after applying these operations. So that is the problem. So how can we solve this? So I think the problem was really hard because it involves a lot of mathematical proof. So I do not recommend you guys to do proofs during the contest. So during the contest, you should not go for proofs, right? If the proof is easy enough, then you can go for proofs. Otherwise, you should try brute force, right? You can write a brute force solution and try to test for small values. Either you can do some dry run on some pen and paper, right? Try to do some dry run on pen and paper, or either you can do proof by AC. So proof by AC means that you can just code out what you are thinking or your intuition, and you can prove your answer that it is correct if you get an AC, right? So during the contest, you can try any of these three methods if you are not able to come up with a formal proof. And after the contest, you guys should try to read the editorial and come up with a formal proof. Right, because the concepts that you learn during a formal or a mathematical proof will help you in the future, right? So I will show you guys the formal proof how we can solve this. So we will start with cases. The very first case is when your n is equal to k. What that means is that you can flip your entire string, right? So we have s1, s2, s3, so on up to sn, right? As my n is equal to k, right? So that means you have to flip the entire string. So either your string is equal to s, or you will flip your entire string, and you will get your new string s1 dash, s2 dash, s3 dash, so on till sn dash. So I will call this s dash, right? So there are only two possible strings, either s, or when you flip the entire string and you get your new string s dash, right? So the following case is simple enough. So when you have your k is equal to n, your answer is simply 2, right? Because there are only two possible strings that you can have. That is your first case. So let's move on to the second case now, that requires the proof work. So your second case is when your k is less than n. So here we have case 2, when your k is less than n. I can further break this case down into two parts, right? So I will have case 2.1 where k is equal to odd, right? So my second case is when my k is less than n, and I will further break this down into two cases, when my k is equal to odd and when my k is equal to even. So when my k is equal to odd, I will try to prove that we can toggle any bit independently. We can toggle any bit independently. And that will help us to solve the problem, right? So let's see how we can prove this and how it will help us to solve the problem. So I will have my string s, right? So I just need to think about the first k plus 1 indexes to prove this. I will just like talk about the first k plus 1 indexes, and I will show that it is enough. These indexes are enough to prove my point, right? That we can toggle any bit independently. So I have my index s1, s2, s3, so on till s4, up to index s of k plus 1. So I have my first k plus 1 indexes, and I will operation, and I will do k operations on this. I will do k operations on this. In every operation, I will select s1. In every operation, I will select s1. So I am doing a tick mark to show that I am choosing index s1 to be flipped. So we are doing k operations on this, right? So in total, these are k operations, let's say. So as we have fixed the one index, right, we need to choose k minus one more indexes. We are fixing one index, right? We have fixed this index. So in one operation, we have to flip k indexes, and as we have fixed one index, we need to choose k minus one more indexes. We need to choose k minus one more indexes from these k indexes, right? These are in total k indexes, right? From s2 to k plus 1, these are k indexes. And from these k indexes, we need to choose k minus one more indexes, right? Or you can rephrase this as, because we are choosing k minus 1, so you can say say k c k minus 1, right? So we are choosing k minus 1 indexes out of k, or you can say this is equal to kc1, that is we are leaving one index, right? So that is another way to rephrase this. So we have to choose k minus one more indexes from these k indexes, or you can say we have to leave one index, right? That is the same thing. So let's say we leave s2 in the first operation. Let's say we leave s2 in the first operation, and we will choose s3, s4, so on till s of k plus 1, and we will apply operations on these. Let's say in the second operation, we will choose s2 and we will leave s3, right? So on till s, right? And then we will choose s2, s3, we will leave s4, and then choose the other indexes, and so on, right? As you can see, it is kind of forming a matrix, right? Where you have crosses, you have crosses along the main diagonal, right? And it is a matrix of size k into k, right? We have a k cross k matrix. So if you see at the end of k operations, how will your string look like? If we try to see at the end how our string will look like. So for the first index, I am doing the operation k times. I am doing the operation k times. So for s1, I am toggling it k times. And as my k is equal to odd, as you can see, right? Because my k is equal to odd. And if we toggle anything k times, it will be toggled, right? So in the end, my s1 will be how much? It will be s1 dash. It will be s1 dash, right? So if I see here, I have s1 dash. Now if you think about s2, right, we are not toggling it k times, right? Because you can see there is a cross here, there's a cross here. So we are not toggling it k times. We are toggling it how many times? We are toggling it k minus 1 times. We are toggling it k minus 1 times, right? And if you have s2 and we toggle it k minus 1 times, as my k is odd, my k minus 1 will be even, right? And if you toggle anything even times, it will remain itself. So my s2 will remain s2. So my s2 will remain s2. And you can use the same argument for s3, right? My s3 will remain s3, and so on up to s of k plus 1, right? So as you can see now, right, only my 1 bit is toggled, only my s1 bit is toggled, only my s1 bit is toggled. So I had my string as s1, s2, s3, so on up to sk plus 1, right? Whatever. I applied k operations on these first k plus 1 indexes, and I was able to flip just s1. I was able to flip just s1, right? So I have s2, s3, so on up to sk plus 1, so on, right? So now I am able to independently flip one bit. Now I can independently flip one bit. So now how can I count the number of strings from this, right? So my number of different strings will be how much? Number of different strings it will just be equal to nc0 plus nc1 plus nc2 plus nc3, so on up to ncn, right? Here my 0 means that I am flipping 0 bits out of n, right? Similarly here I am flipping 1 bit, flip 1 bit, right? Because as you can see, we are able to flip 1 bit, and if we are able to flip 1 bit, we can also flip the second bit, right? Whatever bit we choose, we can flip that bit. So for 2, we are flipping any 2 bits, we can flip 2 bits, right? So I hope that makes sense, right? Because we are able to flip 1 bit s1 dash, so we can again apply k operations and flip some other bit, right? So we can flip 2 bits, and similarly we can flip 3 bits, 4 bits, and up to n bits. And this is a well-known binomial formula, and answer for this is how much? This is just 2 to the power n, right? So when your k is equal to odd, your answer is how much? Answer is equal to 2 to the power n. So that was the case when your k is equal to odd. So let's move on to the case when your k is equal to even. When your k is 2.2, when your k is equal to even. So when your k is equal to even, we will try to prove that we can flip any 2 bits independently. We can flip any 2 bits independently, right? In k is equal to odd case, we were able to flip any bit independently, right? But in k is equal to even case, we have a restriction, right? We cannot flip any single bit. Whenever we will try to flip something, we will flip 2 bits, right? We cannot flip odd number of bits in this case. So how can we show this? So if I have to show this, I will again take the same example. We will have I will have s1, s2, s3, s4, so on up to s of k plus 1. This time we will do k minus 1 operations. This time we will do k minus 1 operations. And in every operation we will take s1 and s2. We will take s1 and s2, right? So now we have fixed 2 indexes. So now we have to choose. K minus 2 indexes out of k minus 1 indexes. So this is just k minus 2. K minus 1. C k minus 2, and this is again like same k minus 1 c1, right? So basically you again have to leave one index. This is again just same as leaving one index. So again we can first of all we can leave s3, right, and choose the other indexes. Again we can take s3 and leave s4 and do the same thing again, right? And we will again have a cross matrix, right? Square matrix of size k minus 1 into k minus 1. So we again have a matrix of size k minus 1 into k minus 1, where we have crosses along the main diagonal. So now if we try to see how the bits are after applying the k minus 1 operations, right? As we have s1, right, and we are applying k minus 1 operations on this, right? Because in every k minus 1 operation we are choosing s1 and s2, right? So we will apply, or we will toggle s1 k minus 1 times, and as my k is even, so my k minus 1 will be odd, right? So if I apply odd number of operations, my s1 will be flipped. So I will have s1 dash. Similarly, I will have s2 dash, right? Because s1 is similar to s2 is similar to s1, so my s2 will also be flipped. And now if you think about S3, right, we are applying k minus 1 operations, and we are ignoring S3 for one operation. We are ignoring S3 for one operation, right? So my S3 will be toggled k minus 2 times. My S3 will be toggled k minus 2 times. So I have S3, it will be toggled k minus 2 operation toggles, right? My k is even, so my k minus 2 will also be even. So my S3 will remain S3. So it will remain S3. Same thing for S4, same thing for S5, and same thing for S of k plus 1, right? So as you can see, in the end, I am able to flip 2 bits independently. I am able to flip 2 bits independently, right? So this is enough to form a solution. So how can we like count the number of strings from this? So different number of strings is equal to how much? First is NC0, that is we flip nothing. Then is NC2, that is we flip 2 bits, right? For example, we flipped S1 dash and S2 dash in this. The second case is when we flip 4 bits, right? That is we flip 4 bits, right? So like we flipped S1 and S2 dash here. So you can like apply same k minus 1 operations, and you can flip some 2 more bits. So we will flip 2 more bits, so we'll now flip 4 bits. So we'll have NC6 and so on to the end. And this is also a well-known formula. So if you guys don't know, NC0 plus NC2 plus NC4 so on is equal to NC1 plus NC3 plus NC5 so on, which is equal to 2 the power n minus 1. This is a well-known formula as well. So if my k is equal to even, my answer is equal to 2 the power n minus 1, and that is enough to answer our problem. So I will summarize the solution once again, so it will be easy. It will be easier for you to understand. So summary. First of all, you have case 1, right? When your k is equal to n. In this, you have only 2 possibilities. So your answer is equal to 2. Then you have your second case, when your k is less than n, and in this you also have cases when your k is equal to odd. You can flip any bit independently. You can flip any bit however you want. So in this case, answer is equal to 2 the power n. And when your k is equal to even, you can flip any 2 bits, right? You cannot flip a single bit, but you have to flip 2 bits at a time. So you can flip any 2 bits. So in this case, answer is equal to how much? Answer is equal to 2 the power n minus 1. So that is the entire solution. I don't think you guys need to see the code for this, but still, if you guys have to, here's the code. So I have my input n and k, right? And as you can see, we are not using a string anywhere, right? As you have seen, the answer is totally dependent on n and k. We don't need to think about s, right? If your k is equal to n, answer is equal to 2, otherwise it is 2 the power n or 2 the power n minus 1. So you are not using s anywhere. So like s is not useful in this. So if your n is equal to k, answer is equal to 2. Otherwise, I will compute my answer as 2 the power n minus 1. And so my answer is equal to 2 the power n minus 1 here. If my k is odd, I will multiply an extra 2. So I will make it 2 the power n. Otherwise, I will just print 2 the power n minus 1. So that is the entire code. It is simple enough. The only hard thing was the mathematical proofs. So I hope you guys are clear with this, and if you guys have a doubt, feel free to join my Discord server. I answer your doubts there, and I will be more than happy to answer your doubts. So yeah, that is it for this video, and I will see you guys in the next one. Also, if you guys don't know, Continue Newton School is offering a full stack development course. The course is over 6 months long, and it is totally based on pay after placement model, and you don't have to pay anything. There is 0 hidden fees, there is 0 upfront fees, and they are granting you a minimum package of rupees 5 lakhs, and the average package is rupees 7 lakhs, and the highest package is over rupees 26 lakhs. So it is a very great opportunity. Also, all their mentors are from top MNCs like Google, Flipkart, Zomato, etc. Also, they will get you placed into the top MNCs as well, like Google, Flipkart, Zomato. So you can learn from the mentors that are working at those companies, and you can land a job at those companies yourselves. Also, you don't need to worry if you guys think कि यार मेरे को भी coding आती नहीं है, मैं भी fresher, मेरे को बिल्कुल नहीं आता है. The course is over 6 months long and they will teach you from scratch. So you can still sign up for this. And if you guys are looking for a career in the tech field, this is a very great head start that you should sign up for. And if you want to land a job, I highly vouch for this. And if you guys want to sign up, there will be a link down below and you can go and sign up from there. So yeah, be sure to sign up for this, and I will see you in the next video. Bye bye.